Welcome to the next lesson in this chapter, which is called Modular Monoliths. Here's a quick introduction of what we are going to cover in this lesson. We are going to explain what is a modular monolith. We're also going to discuss what are the benefits of using modular monoliths, and I'm going to explain what makes a modular architecture. This lesson builds upon the discussion from the previous lesson where we were talking about monoliths and microservices, comparing these two architectural styles, and we were also introducing some important architectural drivers that we need to consider when we are making architectural decisions. By the end of this lesson, you will have a good idea of what a modular monolith is and when you should use it. But first, let's try to answer the question, what is a modular monolith? I'm going to give you a few definitions. They are going to vary in complexity and detail, and hopefully we will be able to understand from a conceptual level what a modular monolith is. So here goes the first definition. A modular monolith is a software design approach in which a monolith system is designed with an emphasis on interchangeable modules. This might be enough for some of you, but let's see another definition. This one is very brief. It says that a modular monolith is an explicit name for a monolith system designed in a modular way. So from these two definitions, we can deduce that a modular monolith is just a monolith system, but there is this emphasis on the word modular. So let's look at the definition of modular to try to understand what is meant by this. So here are two definitions for the word modular. It says consisting of separate parts that, when combined, form a complete whole. And then we have another definition, made from a set of separate parts that can be joined together to form a larger object. And these two explanations are very telling of what we are trying to achieve when building a modular monolith. So our monolith system now consists of something called a module, and these modules come together to form the complete monolith system. Now you will see that there are some constraints that we are going to impose on these modules to make them fit nicely into the modular monolith architecture, but let's not get ahead of ourselves because we are going to discuss this in the next lessons. Keeping the previous definitions in mind, here is a simplified explanation of a modular monolith that I came up with so that I could understand this concept better, and it says that a modular monolith is an architectural pattern that structures the application into independent modules or components with well-defined boundaries. I highlighted the words independent modules and well-defined boundaries on purpose because these are the crucial concepts to understand in order to build a good modular monolith system. Now you might be wondering, what is a module? Well, a module represents a cohesive set of functionalities. So a module is nothing else than a grouping of related functionalities, which is highlighted by the word cohesive, which basically means that related things should go together and related use cases should go inside of the same module. You should be able to treat each module as a separate application. To put this another way, modules should be self-contained. And when you start thinking deeply about these very simple concepts, you will start to understand how a few modules can come together to form a very complex system. So I want to reiterate this again. A module represents a cohesive groupation of connected and related use cases. Each module should be treated as a separate application. This has many implications. For example, each module should have its own data store so that it doesn't have to interact with any of the other modules, which makes it loosely coupled because it doesn't need to depend on other modules to fetch the data. And integrating at the database level is some of the tightest coupling that you can add to any kind of system. But let's try to explain this with a visual example. Here's our conceptual diagram from before, where we have a monolith system deployed in a single container, in other words, as a single deployment unit, and we have a microservices system that contains a few deployment units. Now, we said that modular monoliths combine the physical architecture of a monolith, which means we have only one deployment unit, and the logical architecture of microservices, which means that we should be able to isolate independent components. This is what our modules represent. They are the cohesive, independent groupings of functionality. And if I wanted to explain the concept of a modular monolith using an oversimplified diagram, this is what that would look like. So we have just a single deployment unit, in this example a Docker container containing the entire application. But the important distinction is that we have clearly defined modules that contain many use cases inside. So for example, here we have an events module that could contain use cases pertaining to events, ticket types, maybe event categories. And when I say events in this context, I mean something like a concert or a movie or a theater show, something like that. We also have a users component or users module. We have an attendance component, and you can start to see how these components can interact with each other. So an attendee is just a user attending a specific event. And we also have a ticketing module, and you can begin to see how it fits into the system. So it's responsible for managing the ticket sales for a particular event to a particular user so that they can attend a specific event. One more thing that is very important for a modular monolith is the existence of a public API. Notice how the modules in this diagram are only communicating using the public API. And this is one of the most important constraints for module communication, and that is that they should only talk through the exposed public API. I'm going to explain what is a public API in a future lesson, but for now, just understand that we're going to use the concept of a public API to talk between the modules inside of our modular monolith. And of course, we have just a single database, although we could have more than one database. However, let's keep it simple and say we have one database, which means we also get immediate consistency. Hopefully, now you have a better understanding of what a modular monolith is. But you might be wondering, as you should, what are the benefits of building a modular monolith system? I'm going to highlight a few modular monolith benefits that I consider important, and this is by no means an exhaustive list, but let's start with high cohesion. Cohesion is a quality of our system where we place related components closely together. This makes it easier for these components to communicate with each other and evolve over time, and it also makes it easier for us as developers to maintain a highly cohesive system because all of the components that we would need to work with are already placed close together inside of the system. Another benefit of modular monoliths is loose coupling between the modules, and a few things facilitate loose coupling, mainly the existence of the public API and the constraint that the modules should only talk to each other using the public API. Inside of a modular monolith, we are also going to enforce isolation of data between the modules, which is another way to reduce the coupling between the modules. Simplified deployment is another benefit, and this comes from the fact that we are building a monolith system, which means we have only one deployment unit. Another benefit is improved performance, which might seem vague at first, but what I mean by this is that a monolith system doesn't have the overhead that a microservices system has. So our components or modules can talk using simple method calls that are in memory, which are both fast and efficient, and we also don't have to think about authentication between the modules, and we also don't have to think about serializing the data and sending it over the network. So in that regard, we do get improved performance when using a monolith system. Lower operational complexity compared to microservices might be something that doesn't often cross your mind, but it's definitely important when you are considering what type of system to build. When it comes to modular monoliths, lower operational complexity is evident from the fact that we have very few moving parts. We have one deployment unit and typically just one database. We could have a caching system like Redis, and this will probably be sufficient for your system to keep functioning in production for a very long time. Modular monoliths are also easier to transition into a microservices system compared to just a monolith. And this is because a modular monolith is already logically isolated into modules. And when the time comes that you want to transition into microservices, a single module is most likely going to match a service boundary that you will want to deploy as a microservice. I'm sure all of these benefits about modular monoliths sound nice in theory, but how do you actually build a modular monolith system? Let's try to explain this by understanding what we need to achieve a modular architecture. So to achieve a modular architecture, our modules need to be independent from each other and interchangeable. We make our modules independent by making them highly cohesive, so we group the related functionality closely together. We only allow our modules to communicate through a public API, which gives us loose coupling, and we make sure to isolate the data for each specific module in the database. Another thing we need is that our modules need to be able to provide the required functionality. If this isn't the case, we don't really have anything, because without the required functionality, our system doesn't provide any business value. And one more thing we need our modules to have is a well-defined interface exposed to the other modules. When I say interface or public API when it comes to a module, I am not necessarily talking about a C# interface, which is a code-level construct. We are talking about a conceptual interface that we are exposing to other modules in their system, and this interface should clearly define what you can do with the given module. For example, an interface should expose a set of operations on a given module that you can call to either get some data from this module or invoke some sort of operation that is going to cause some side effects. Here's a diagram that should help us understand modularity better, and you can see some different architectural styles in regards to the number of deployment units and the modularity. So we have the traditional monolith, a modular monolith, a distributed monolith, and a microservices system. On the horizontal axis, we have the number of deployment units, and on the vertical axis, we have modularity. So if we go up the horizontal axis, the number of deployment units increases, and if we go up the vertical axis, the modularity of the system increases. So at the bottom, with the lowest modularity and the lowest number of deployment units, we have the typical monolith system. Modularity is low because the logical isolation between the components inside of a monolith is typically not as great. If we increase the modularity of our system, we get a modular monolith because we are grouping the related use cases together inside of independent and interchangeable modules. A distributed monolith is probably the worst scenario you want to end up with, and this represents a system that is deployed like a microservices system, which means it has many deployment units, but it's implemented like a monolith system, which means that components are tightly coupled. You aren't able to independently deploy your services because they are so tightly coupled that if one service goes down, the entire system goes down. And then in the upper right corner, where we have many deployment units and good modularity, we have a microservices system. If you compare microservices to modular monoliths, what you can see is that what is a module inside of a modular monolith is now a service inside of a microservices system. And this isn't at all accidental. Many teams end up using microservices to enforce boundaries in the code or logical boundaries. So basically, what could be modules are now deployed as services, instead of just learning how to build a nicely structured modular system without having to deal with the complexity that microservices and distributed systems bring. If we wanted to compare modular monoliths to microservices, we could say that microservices elevate the logical boundaries or modules inside of a modular monolith into physical boundaries or services. So a big advantage of microservices is that they give you a clear strategy for modularizing your system and decomposing it into specific bounded contexts or services. However, a big problem is that people end up misusing this quality of microservices, and they build microservices to simply enforce code boundaries. Instead, you can just build a modular monolith, get most of the same benefits of microservices without any of the complexity. And this ties very nicely into the concept of evolutionary architecture. Evolutionary architecture is an approach to building software that's designed to evolve over time as your business priorities change, as your customer demands shift, and as new technologies emerge. For example, the emergence and wider adoption of artificial intelligence. So the general idea of evolutionary architecture is structuring your system in such a way that it solves today's problems, but that you can also evolve it to solve tomorrow's problems. In that regard, we can definitely say that modular monoliths are evolutionary, and this is because we have well-defined in-process components that we call modules, which are an excellent stepping stone for out-of-process components or services. So if there is one point that I want you to remember from this lesson, it is this: well-defined in-process components or modules can be an excellent stepping stone to out-of-process components or services. Which brings us to the end of this lesson. In the next lesson, we are going to talk about module constraints. Module constraints are rules that we want to enforce inside of a modular monolith, and they allow us to develop modules that are independent from each other, interchangeable, loosely coupled, and most of all, highly cohesive.